So this is my 5-image meteorology story. So first we have the circulation of the atmosphere. So as seen in the picture, hot air rises in the tropics. It moves north or south. It descends and returns in the equatorial Hadley cells. And then its path along the Earth's surface is bent into trade winds thanks to the Coriolis effect that's caused by the Earth's rotation. Two other cells in each hemisphere work similarly to what I just described, and so it's thanks to the sun's heat and energy and the Coriolis effect that we get circulation from the equator to the poles. So that's how the circulation of our atmosphere works in moving around. Next we have wind direction. And you can see that wind is formed by horizontal air movement. It's a result of horizontal difference in air pressure. Wind always moves from high to low pressure. Wind is affected by the pressure gradient, the Coriolis effect, and friction in the lower pressure only. What initially sets air in motion? It's the difference in air pressure. It's a main factor in wind direction. Wind travels from the areas of high pressure to low pressure. Heat and pressure cause the wind to shift directions. Wind is affected, as I said, by the pressure gradient, the Coriolis effect, and friction at lower levels. Wind likes to go from high to low pressure naturally because high pressure has more air molecules in it and it's crowded. So naturally the molecules want to go to where it's less crowded, and that's the low pressure. The greater the pressure and the difference, the stronger the wind. The Coriolis effect is our next. It is due to the Earth's rotation. Wind moves in a straight line, but because of the Earth's rotation, it deflects and looks curved. This affects wind direction. It acts at a right angle. Thanks to this, we have our different rotation in our southern hemisphere than our northern hemisphere. Our northern hemisphere has a counterclockwise rotation, where in the low pressure zone, whereas in a high pressure zone in our northern hemisphere we'd have a clockwise rotation. And then just as different in a southern hemisphere, we'd have a counterclockwise rotation in a low pressure, whereas a high pressure we'd still have that counterclockwise rotation. So it affects how the wind moves. So why air rises and descends? It's when the surface is heated, the air on the surface heats up. The warm air is lighter, so it rises. It reduces the pressure locally, so it rises up. And it's lowered the air pressure in one area, so the wind then blows toward the low pressure zone. It's like a balloon full of air. When you let it go, it bursts away. So just like you see in the picture, with a sea breeze on the land, you have the land being heated from the sun. So the warm air is rising. It then goes over to the ocean where there's cool air and it descends, and then we get that nice breeze from going inland. Whereas when at nighttime, the cool air descends on the land because the land is going to cool faster than the ocean. Lastly, we have how circulation impacts climate. The difference of the wind at various levels in the atmosphere determines the local climate and steers our weather systems. The circulation of wind in the atmosphere is driven by the Coriolis effect and the rotation of the Earth and the incoming energy from the sun. It's how we get fronts, and the fronts are the boundaries between different air masses. Fronts can cause air to lift, so we've seen already that we have warm fronts, cold fronts, stationary fronts, and occluded fronts. This is also how like tornadoes are formed. A front develops, and then a wave develops, and then we saw that a cyclonic circulation is established, and then occlusion happens, and then an occluded front, and then the cyclone dissipates. So how the air circulates completely impacts our climate at a global level and a local level. Thank you for listening to my presentation.